Dear physics aspirants, right now I have the energy stored in a capacitor, electrostatic potential and capacitance. When you study in physics, then you will get this topic. Within this topic, we will require to understand our understanding regarding the capacitors and why capacitors will be needed, electrostatic force when you study the various electronic devices, UPS and other electronic devices, television and other many more devices require the capacitance for the electrostatic potential. The uh, capacitor where you will see the formula delta W and V dash delta, the variable, and Q dash is equal to Q dash by C century and delta Q dash. uh, yeah, here you will see in transferring positive charge from a conductor 2 to conductor 1, work will done externally, and you will see here the variables and plus and minus sign. You will see work done in a small step of building charge on conductor 1 from Q dash to Q dash plus lambda Q dash, where work done in charging and capacitor may be viewed as stored in the energy of electric field between the plates. In a capacitor, as we seen above, the system of two conductors with charge Q and minus Q. To determine the energy stored in this configuration, consider initially two uncharged conductors. These are the uncharged conductors you will see 1 and 2. Imagine next, consider next process of transferring charge, then uncharged capacitance. You will see capacitors, and now next will be the charge transferring from conductor 2 to conductor 1. Conductor 2 to conductor 1 you will see here, and I would like to ask you that um, here you will see the bit by bit, slowly in small steps, and so that the end conductor 1 gets charge Q by charge conservation, conductor 2 has charge minus Q at the end, because charge is transferred to 2 to 1, as we see here in the detailed description. In transferring charge to conductor 2 to 1, work will done externally, since at any stage conductor 1 is the higher potential than conductor 2. The potential is very very important factor that they uh, pull the charges from other capacitors. To calculate the total work done, we first calculate the work done in a small step involving transfer of an infinitesimal, vanishingly small amount of charge. Consider the intermediate situation. When conductors 1 and 2 have charge, the Q dash and Q minus Q dash respectively, at this stage, the potential difference V dash between conductors 1 and 2, Q dash by C, where C is the capacitance of the system. Next, imagine that a small charge lambda variable and Q dash is transferred from the conductor 2 to 1. Work done of the steps lambda W dash resulting in charge Q dash on conductor 1 and increasing to Q dash, and lambda Q dash is 1 given here. And other formula is here for your understanding. Summation is here, total and variable integration you will see here, the based on the calculus formula you will see here. I am describing this content from the NCERT plus 2 level book, and note that energy density of electric field is U is equal to half E 0 E square, and dog we derived equation 2.77. So here you will see the very general and holds true the electric field due to the any configuration of charge. So the charging capacitance and variables you will get when you see, because the capacitors is a very important factor for electronic devices. When you see the electrostatic and potential and capacitance, then this chapter will be very important for you. And here you will see here the 2.10 numerical will provide you the solution also, and with the solution you will memorize the factor and you can understand. We will meet in next discussion with a lot more. Till then, thank you.